Guys, welcome back to this exciting series in mechanics. I hope you're enjoying it. I hope it's helping. In this one, we're going to look at problem 253 in the 13th edition. This is from section 2.3. Okay? So remember, chapter 2 is all about the basic ideas. How do we add up vectors, force vectors? Okay? And this problem is something that I haven't really covered yet for various reasons, but maybe I should just include it for completion's sake. Okay? If you can see this problem over here, it is a minimization problem. Okay? So it's 253. It says determine the magnitude of force F. Okay? So let's just have a look at. Okay, we have a bracket here. Okay, let me just get that right there. We have this bracket and we have a force of 14 kilonewton in that direction, 8 kilonewton along the horizontal axis, and we've got this F that's coming in from that angle at 45 degrees. Okay, so we don't know what is F. Okay, so it says determine the magnitude of the force F so that the resultant force of the three forces, right, is as small as possible. Okay? So what is the magnitude of F so that, what is the magnitude of this force so that the resultant of these three forces is as small as possible? And then we need to determine what is the resultant of that result, what is the magnitude of that resultant force. Okay? So how do we go about solving this kind of problem? Okay? Well, the first thing, let's write it out then on the paper. Okay? So sorry that my paper's so creased. It's can blame the matrix for that. Okay. So what we have here is I'm going to show you two methods. Okay? The first is a graphical, which I believe is very valuable because it gives us an intuitive feel. And then I guess the other one is just the analytical or the mathematical one. Okay? So let's just first draw this problem. We have a force here that's 8 kilonewton. We have a force coming down there. F, we don't know what its magnitude is. We do know what its angle is. And we also then have a force coming up like that of 14 kilonewton at 30 degrees. Okay? So we will just assume our axes in that way, in that fashion. So we've got our x coming along here and our y there. Okay, straightforward. So the question is, what is the value of f so that the resultant of these three is a minimum? Okay, so remember, guys, a vector has both a magnitude and a direction. So what we've got here is we've got a direction for this force, but we don't have a magnitude. You got that? For this one, we've got a magnitude and a direction, and for this one, we have a magnitude and a direction. Okay, so the way that I would like to do this, okay, is I'd like to just simplify this problem and because I know this force vector, I know everything to do with this force vector, and I have all the information for this force vector. I'm going to add them up and get a resultant, and I'm going to leave this one untouched. Okay? So you can use whatever method you want. Okay, so guys, what I'm doing is I'm adding this force vector to that force vector. I'm pretty sure you can do that. That is very straightforward. Okay? I'm not going to go through the calculations to add this up. Just you add up the x, you find the x component of this, you add that to the x component of that, then you add the y components and you get a resultant. And what I get, I'm not going to go into that calculation because I think you've got the skills to do that, and I'm not going to, that's not the point of this exercise. The resultant of these two force vectors, okay, if I can just find is a force vector, okay, which has a magnitude of 8,124 kilonewton, okay? And it has an angle of 59,5 in the clockwise direction when measured from the negative x-axis, okay? So again, I'm going to repeat, please don't get confused. I've got three forces here, but the first thing I'm going to do to simplify the problem is add up this force vector and that force vector. And when I add these two up, I get this. I get a force of 8,124 kilonewton with this angle. Okay? Now, if I go and add this, I can still add this F in here at 45 degrees. Okay? So now what I've done is I've simplified my problem. Now I've got two forces. Okay? Let me just give this a name. Say, let's call it F1. Let's call this that force plus that force vector gives me F1. I've added these two up and I've gotten that one, magnitude and a resultant. Okay, I hope that's very clear. Now, remember that this force vector plus this force vector should give me a resultant. So I'm going to write it here. My resultant in vector form, wherever that is, whatever it is equal to F1, which is that one there, plus this unknown F. Okay? So we don't know what is FR and we don't know what is F. We do have a bit of information for F. We have this angle. Okay. So guys, this is this is the basic idea that we need to really understand from chapter 2, is that the resultant force is simply the sum of the forces. Okay? So, what does this mean? It means that this force vector plus this force vector should give me a resultant force vector. Now, what I want to do is, I want to, maybe I can even move over here and redraw it. Okay? We have our F1, okay, which is 8,124 with a 59,5. And I'm going to now use the head to tail method. Okay? Head to tail. It's the same as the parallelogram. Okay? But all I'm doing is, instead of drawing it like this and then using the parallelogram method, I'm just going to take this force and place it there at the head to tail method. Okay, I'm going to use the head to tail method. So there we have our F now. Okay, there's our F and we have our F1. Okay, are we still clear? Now we just put in some angles. Remember, this is 59,5. You'll see why I'm doing this. Okay, we have 59,5 and we know that this is a right angle, and we know that this then becomes 30,5. 59,5, that becomes 30,5. Okay? Now, look again at this. The resultant force vector is equal to F1 vector plus F vector. Okay? So, F1 plus F equals FR. F1 plus F equals FR. Okay, is that clear? We've simply done vector addition. This force plus that force gives us our resultant force. Okay? Okay, I hope that's clear. And what is this angle here? This angle is also 45. Where does it come from? It comes from here, 45. So if we extend this, we'll see that that's also 45. Right? That's 45, of course. Okay? I hope you can see that. Because that's 45, these angles are 45. Then if I just transplant this using a head to tail method, then we have a 45 degree there. Okay. So now we have our diagram, and that's what I said earlier, is we're starting with graphical. I really like the graphical method. It really it helps me understand. So now, again, what we have here is we have a a force F1, and we have 30,5, and we have this F1. Not sure why I keep drawing it over and over again, but here we go. There's FR, okay, F1. Now, this is the important thing which I'd like you to take note of, is that if we know, remember what I said earlier, is that a vector, a force vector, has both magnitude and it has a direction. Okay? What do we know about F? What do we know about F? All we have is a direction. So when we're working with these minimization problems, we are able to change one thing, basically, and see how it affects another thing. So in this case, we can change the magnitude of F and see how it changes the magnitude of FR. Because remember, the question said, what is the value of F, the magnitude of F, so that FR is a minimum. Okay? So can you see, what are we able to do here? We are able to change the magnitude of F and then try to see what is the magnitude of FR. Okay? So F1, so we can't change anything to do with F1, guys. Why is that? Because the magnitude and the direction is fixed. It's fixed. It's given. We've calculated it. Right? You can't change it. What can we change? We can change, sorry, that shouldn't be F1. We can change F. We can change the magnitude of F and see how it affects FR. Okay, so we change F and we calculate FR. We change it again. We see what FR. We change F again and we see what is the resultant. And we are trying to find the F so that this FR is a minimum. Now, using the graphical method, what I want you to see here is, say now we make F large. I don't know what F is, right? Make it very large. There's my F, right? We've got the angle. We can't change the angle. We can only change the magnitude. So say, let's make it large. And then F1 plus F must equal FR. Okay? Now, can you see that this FR is, just by looking at it, you can see that this FR, based on this large F, is larger than this FR, based on that F. Okay? So if we start large, and we keep reducing it, say now we reduce our F to this size, and there is our FR. Can you see that if we keep reducing F, FR is getting smaller and smaller? Can you see that? Right? That F is smaller than that F. That FR is smaller than that FR. And that FR is smaller than that FR. As we are modifying the magnitude of F at this 45-degree angle, as we are reducing it, FR is getting smaller and smaller. So then, what about, let's look at one option. Let's make it even smaller so that we have a right angle there between FR and F. Okay, does that make sense? I keep reducing it. Right? Here we have acute angles. There's an acute angle. Now finally we have a 90-degree angle. And what happens if I keep reducing F to say that size? Okay? And I've got my another FR there. Can you see that if I extract these two triangles, that triangle and that triangle, I'm going to get something that looks like this. There's one triangle, there's my other triangle. So that line there is this one, and that line obviously is that one, and that FR refers to that FR. So my point is, guys, as we are reducing F from a large value, our FR is changing value. It looks like it's getting smaller here. But then what happens is once you go past the 90 degrees, it starts getting larger again. Can you see here? Imagine if we had all these, imagine if this was your F and these were your FRs. Okay? Right, because remember this F, we can't change its direction, we can only change its magnitude. So can you see, guys, that once you go on either side of the perpendicular line, remember this is FR and that is F, can you see that FR begins to get larger? Okay? So based on this graphical method, we can see that for FR, the magnitude of FR to be minimum, these vectors F1 and FR must be perpendicular. Can you see that? There's FR and there's F1. They have to be perpendicular to each other. Okay? So this really helps us now in the rest of our calculations, because now we know what the drawing should be. We know what the drawing looks like. Okay? And we should have our F1. Okay? We should have, and then we should have a resultant that comes up like this. And this is my FR, and that should be my F. And there must be a 90 degree there. Okay? So I really hope that makes sense. So now, we know that this should be 90 degrees. This angle there should be 45 plus 30, 5, okay, which we got earlier, 45 plus 30, 5, which equals 75, 5, okay. So if we calculate this angle, it should be 14, 5, because angles within a triangle should equal 180. 90 plus 75, 5 plus 14, 5 equals 180. But we already know what is the magnitude of F1. It is 8,124 kilonewton. So, because we've got a right angle triangle, we can say that FR, the magnitude of FR, is simply 8,124 cos get the light right, cos 14, 5, which equals, if I'm not mistaken, 7,865 kilonewton. And the magnitude of F is equal to 8,124 cos 75, 5, which equals 2,03 kilonewton. Alright? So this is the graphical method, guys. Let's go through it again. I first calculated the resultant of these two. I got this force here. Then, based on normal force vector addition, I know that that force plus that force must give me a resultant, which is what I got here, using the head-to-tail vector addition method. So F1 plus F must give me FR. But then what I saw was, as I modified F, FR changed every time. And what I found graphically was that when F1 and FR are perpendicular, then we have FR being a minimum, okay, which is also shown here. So then using this graphical method, I knew that that is a 90 degree. I knew that was 75, 5. I have the magnitude of this, really this hypotenuse, which was my 8,124. I've got all these angles, and using cos, using my cosines, I found what FR is at a minimum, right? And I found what F is 2,03 in order to give
FR, make FR a minimum. Okay? So I think that's good enough for now. That's the graphical method. The next video I will work on the analytical or the mathematical method. Okay. Thanks guys. I really hope this helps. Cheers.